we're going to take a look at this concept of climate change. Sometimes it's called climate change, sometimes it's called global warming. But when we talk about climate change or global warming, people are always talking about greenhouse gases, and that we need to limit the amount of greenhouse gases that we produce. So we're going to learn all about, what is a greenhouse gas? What does it have to do with global warming? How does it affect us? Is there anything we can do about it? Is there anything we should do about it? So it's going to be kind of an interesting story to tell. So I hope that you take advantage of the opportunity to follow along and read along and try to understand for yourself, what is the chemistry behind global warming. Now, before we get started, talking about global warming, since we refer to the gases that contribute to global warming as greenhouse gas, I thought we better just take a minute to make sure we all know what is a greenhouse. A greenhouse is a place where people typically grow plants or fruits and vegetables. It is a place where you have either a glass surface or a plastic surface that allows the visible light in and the visible light out, but it has a way of trapping heat. So for example, if it's still cold outside and you want to start growing some flowers or some plants, the seeds won't germinate if it's too cold. So you plant them inside the greenhouse and start growing your plants. Sometimes the plant is grown to maturity in the greenhouse. Sometimes plants are grown and then transferred to, transplanted, and they finish growing and producing their crops outside the greenhouse. But the bottom line is that it's warmer on the inside of a greenhouse than it is on the outside of a greenhouse, and visible light can clearly get through. Right? So since greenhouses are covered with either glass or plastic, and we refer to gases as greenhouse gases, it might be useful to take pause here for a minute and talk about how can a gas be like a glass. Okay, so everybody may not have been inside a greenhouse and experienced how it can be colder outside and warmer inside. So I thought but everybody has probably experienced getting inside a hot car. So let's take a minute and understand, how does the inside of your car get hot? Hotter than the outside. So if you remember from the last unit, we talked about the electromagnetic radiation that's emitted from the sun. And we said that the majority of the electromagnetic radiation that is emitted from the sun that makes it to the earth is in the form of ultraviolet, visible, and infrared radiation. We learned in the last unit that most of the ultraviolet radiation is absorbed in the upper atmosphere by either oxygen or ozone before it makes it to the surface of the earth. The reason why is because it is high energy. It is the right energy to be absorbed by the bonds in the oxygen and the ozone, and so literally that ultraviolet radiation is transformed from radiant energy to chemical energy, and so it becomes a different type of energy. However, the visible and the infrared radiation does make it to the earth, obviously, and can make it to your car on the surface of the earth. And what happens is the visible light can pass through the windows in your windshields, in your windows. And the visible light, once it's inside, some of the visible light will, be reflected and then emitted back out through the window. But much of that visible light is absorbed by the interior of your car, especially if the interior of your car is dark. Dark colored material absorbs most of the visible light. When that light is absorbed, causes the electrons in those materials, because remember, everything is made of protons, neutrons, and electrons, and it's largely the electrons that are doing the business of matter. And so the electrons will be jostled around, and the energy, some of the energy from the visible light will be transformed into the movement and the motion of the electrons in the material. Some of it will then be emitted back from the material, at a lower energy, and the lower energy is in the form of infrared radiation. And infrared radiation cannot pass through the windows of the car. It's just going to be absorbed by everything inside the car and the gases inside the car, and that's how heat in the form of infrared radiation gets trapped inside your car and raises the temperature inside the car. So that's glass trapping the infrared radiation. How does a gas, because the earth is not covered in a big piece of plastic or a big sheet of glass. So I've tried to blow up this picture a little bit. This is directly from your textbook, so you can always look at the book. But what happens is the radiant energy, is some is absorbed in the atmosphere, some is absorbed by the earth, some of it is reflected from the atmosphere off of dust particles or aerosol particles, little bits of water, and some of it is reflected back from the surface of the earth. Now the reflected is going to be reflected in the form of visible light, reflected in the form of visible light. The absorbed by the atmosphere, it's the infrared radiation that's being absorbed by the particles, by some particles, some molecules in the atmosphere. And the visible and the infrared both can be absorbed by the earth. The visible that is absorbed then will, some of it will be re-emitted as infrared radiation. And so this is what we see over here, is some of the energy that was absorbed by the earth, the continents and the oceans and whatnot, is then emitted at longer wavelengths, lower energy, and the absorbed is visible, and some of it is absorbed also as IR, and then re-emitted by IR, lower energy. And that IR, very small amount of it is going to make it all the way and be emitted from the surface of the earth out into cold outer space, just a very small percentage of it. Some of it is going to be absorbed by the atmosphere, though. Most of it is going to be absorbed by the atmosphere, and those gases that absorb the infrared radiation then are going to emit it in all directions. Some of it will then be emitted back out into the atmosphere, into outer space, and some of it will be just reabsorbed by the gases in the atmosphere. Okay, so we don't have a solid glass or a solid plastic sheeting around our atmosphere, but what we do have is some molecules that are capable of absorbing that infrared radiation and just radiating it back down, and this is how we keep our atmosphere warm. All right, so it's not exactly like the glass in a car or the glass or the plastic in a greenhouse, but it behaves in a similar way.